Okay, so we're going to be looking at ways to write exponentials in log form and ways to write logs in exponential form. So we've done a little bit of this, but not a lot. So if we have log base a of y equals x, that is the same thing as a, swirl it around, a to the x equals y. These are equivalent. So what would be equivalent to this? Well, you have to find the base. What's the base, you guys? B, so we have to do b to what? To the m equals n. Good job. So these are going to be also equivalent. If we're asked to find inverses, then we have to switch x and y. We switch x becomes y, y becomes x. So if I want the inverse of this in log form, all I do is I do log base a, I switch y to x, x to y. So that would be the inverse in log form. They also want us to find the inverse in exponential form. Well, I can take this inverse and then just switch it into an exponential. Spencer, how would this be as an exponential right here?
Is the base a?
Mm-hmm.
So be a to the y equals x.
Good. All right, so this is an inverse of that as well as this is an inverse of that. Okay, so now evaluating. Evaluating is pretty straightforward. We're just going to set this equal to x, and then we're just going to rewrite it in exponential form. So we find the base, we go to the across, so it's 3 to the x equals, back to here, 1 over 81. So if we have 3 to the x equals 1 over 81, Michael, T, what's that going to be then? What's x going to be? -4. Good job. Remember, you can also use your calculator to evaluate logs. If I didn't know this answer, I could use my calculator. I could go to math. I could go down to log base. We're going to have log base 3 of 1 over 81, and it'll tell me the answer is -4. Good question. If you don't have log base on your calculator, you have to use change of base, which is this. Log 1 over 81 divided by log 3 is how you'd have to type it in. It's that pattern. Log over this divided by log of that, and it'll still give us the answer. Okay? So here's the formula for it if you need it. Log base a of b is log b divided by log a. All right, so on the next one, just put it equal to x, swirl it around, 6 to the x equals 1. And what is that going to be, Nick? 0. So this answer is 0. On this one, just set it equal to x. We're going to have 125 to the x equals 5. You have to think, what do we do to 125 to get it back to 5 as far as exponent goes? Avery, what would we have to do? 125 to the what? 1/3. Good. If you're not sure about that, if you feel like you might have messed it up, you can do log 5 divided by log 125. And it'll tell you it's 0.3 repeating, bracket, and it's 1/3. All right, do the next one on your own. Swirl around. Madison, what is it? 1/9. Good. Okay, number 4, pretty easy. Find your base. Swirl it around. Now, this is a little bit tougher, though, because you want to rewrite this with something that's a fraction instead of a decimal. Natalie, do you know 0.01 as a fraction? Good. So this is 10 to the x equals 1 over 100, and then you can probably figure it out. Natalie, you know what it would be? Right. Okay, this one, a little bit tougher. If we have addition and we have these x's, what do we do to these values? What are you supposed to do with them? Multiply them. So it's going to be log base 5 of x times x minus 4 equals, and then what is log base 3 of 3? Just 1. So once we get this down to a single log, then we can solve it. We just find our base, swirl it around. How do you solve something like that? Get it set equal to 0, so it's x squared minus 4x minus 5 equals 0. Factor it. And so we get 5 and negative 1, but we know we're not allowed to have a negative 1 there. Here's why. Watch if I were to plug this back in and try to do math, log base. So I'm doing log base 5 of negative 1, and watch what happens. It's going to give me an error message. It says that's non-real. And that's because 5 to nothing, there's no value that I can raise 5 to get negative 1. So we can't have a negative answer on that. All right, solving. First thing we want to do is to get rid of this coefficient. Sometimes I see people multiply 3 times 5. You cannot do that. All you can do is divide by 3. So we will now have 5 to the x minus 1 equals 86 thirds. Well, now I have an exponential function. If I want to go from an exponential to a log, I can do that. It's going to be log, find the base, swirl it around. That's what it would turn into. That's the equivalent log form. Again, what I did, log of the base, swirl it around, equals the exponent. And so now to find the exact answer, I would just add 1. So it's log base 5 of 86 thirds plus 1 equals x. If I wanted to find the decimal approximation, I could do math, go to log base 5 of 86 thirds. Get that answer, add 1 to it, and that would be the solution in decimal form. But we're going to find exact answers. For letter B, just swirl it around. 2 to the second equals radical x minus 4. 2 to the second is 4. What do you do now? Square both sides, we get 16. Add your 4, 20 is our solution. Last thing here, what's true of these two? Are they going to be the same or are they inverses? So here's the first one, here's the second one. What do you guys think? Are they the same or are they inverses of each other? Inverses, most people are saying? All right, well, let's change this into an exponential so we can see better. If I find my base, swirl it around, this is equivalent. Are these two now equivalent? No. X turned into y, y turned to x. So that means they are inverses. All right, let's go over to the notes for Thursday now. This has to do with exponential growth. Some of you are probably going to get some money for graduation, right? Might have a party, invite some relatives or whatever. Might make some money. So we're going to be looking at how does that money grow based on interest rates. Interest rates right now are pretty low, which is a really good thing if you're going to be buying a car or if you're going to be buying a house. But low interest rates are not so great if you're going to be putting your money into the bank. Okay, so we're going to look at some typical interest rates right now. 1%, that's pretty typical standard interest rate you could get now. And then a 3.5% interest rate. The only way you're going to get that high of an interest rate is if you put your money into a CD. Does anybody know what a CD is? And I'm not talking about the old kind that would make music. I'm talking about a CD as far as banking goes. You guys know what it is? You might know? You've never put money in a CD? It stands for Certificate of Deposit. What it means is you have to put your money in for a certain amount of time and you're not allowed to touch it. If you do take money out of it, then you have to pay a very high penalty. So that's why CDs give you a higher interest rate, because the bank knows they're going to get that money for a certain amount of time. If you just put your money into any savings account, you can take it out at any time. You can say, hey, I want that money to buy a car. So you just take it out after 6 months. So the bank has no guarantee that they get to keep it. So we're going to look at these two situations. We got Tim, he's got $3,500. He found a savings account with a 1% interest rate compounded quarterly. We have Krishna, she's got $3,000. She's going to put hers into a CD, 3.5% interest rate compounded quarterly. So Krishna's starting off with significantly less money than Tim is, but we want to see what's going to happen at the end. Does it really matter? A 1% versus a 3.5% interest rate, does that really matter any? So let's take a look and see. So they're both 18 right now. They're going to take out the money when they're 26. So let's work with Tim's amount first. So we're going to have A equals, we're going to be using this formula right here. So his initial principal is $3,500. We're doing 1 plus, his interest rate is 1%, so that's 0.01. Compounded quarterly, so that's 4 times a year. Raised to the N is the number of times it gets compounded, which is 4 again, and then the number of years. Well, if they're 18 now and they're going to take it out when they're 26, that's going to be 8 years. So T is 8. All right, so now we just plug this into our calculator. And you should get $3,791.13. So with that 1% interest rate, he made a whopping $291.13. That's not so great for leaving your money in the bank for 8 years. Okay, that's really not that great. However, if you think of this, like, what if he had started with $3,500,000? Watch this. So if I just insert 3 zeros to make it $3,500,000, now he's going to make what, $291,126.24. You see what I mean? You might have heard the phrase before, it takes money to make money. Well, if you have a lot of money, even if you only invested at 1%, you're going to make $200 and some thousand, okay? $200 and some thousand, that's a lot, okay? But when you're only investing this much, you're only going to make 200. It's all proportional. All right, well, let's look at Krishna now. She's got her 3,000. And we've got 1 plus, and then her interest rate's 0.035, still compounded quarterly, still 4 there, and 8 years. So the only thing we're changing is her starting amount is much less, $500 less, and she has a higher interest rate. So let's see how hers ends up. So we're going to do 3,000, 1 plus, and she ends up with $3,964.56. So she started with only $3,000, but she made almost $1,000. She made almost 33% of her money, almost a third of it. Whereas this situation, what is that? Like, he made 291 out of 3,500. So he's basically getting 8% in that amount of time overall. A big, big difference. Okay? So what you want to see here is, if you are one of those people, you get some money from graduation. If you know you don't need that money for a while, put it into a CD, get a high interest rate, and you'll make a fair amount of money. But if you just put it into a checking account or a savings account where you're only getting 0.5% or 1%, it's almost not even worth it. Have you guys heard of the cost of living? Do you know what the cost of living increase is about every year? That just means, like, however much it costs you to live this year. Typically it goes up between 2 and 3% every year. So if you put your money in the bank with a 1% interest rate, you're actually losing money if you keep it in for a long time, because the cost of living goes up 2%, so you couldn't even buy the same things. You know what I mean? Because everything's getting more expensive all the time. All right. Let's look at this last situation. So we've got Camden. She's got $3,000 that she's going to put into account with 3.5% interest. So kind of similar to what Krishna's was, but she has it compounded continuously. Sometimes banks will do this kind of thing. They'll say, hey, we're going to give you a lower interest rate, but we'll compound it continuously. And you think, oh, well, that sounds great. That should be a good deal. But let's see what happens. Is there really a big difference between compounding that interest 4 times a year versus compounding it continuously? Well, here's our formula for continuously compounding it. It's going to be A equals our principal, 3,000, and it's going to be E to our interest rate, 0.035, to the T, which is still 8. So 3,000 E to the 0.035 times 8, and that's going to give us $3,969.39. Not really that much different, is it? She made an extra $5 over that amount of time. So the point to this is, if they say, hey, instead of giving you that 3.5%, we'll give you 3%, but we'll compound it continuously. Would you go for that? No. I mean, even 0.5% makes a big deal over amount of time. So this is much more important than the number of times that it's compounded. Okay? And then the last part, what is the rate of change of A? Well, now I have to go back to my original formula here. Okay, that's our formula for all the time. P-E to the RT. And we're going to find the rate of change. Well, what does rate of change mean? It just means to find the derivative, right? So this is going to be A prime equals, we bring down the coefficient. The derivative of e to the u is still e to the u, but times the derivative of u, which is 0.035. And to find that rate of change, we're just going to plug in our t values. So it says, what's the rate of change at 3 years? And it's $116.62. Okay? So what that's telling us then is at 3 years, if you keep it in, you're going to make an additional $116.62 when you go from 3 to 4 years. Okay? All right, any questions over any of that? All right.